Okay, question number 4, the probability question. A claim is a request on the insurance company for payment after an incident. X be the random variable of the claim of thousands of dollars. So that 2.3 is 2/3 times $1,000. So around about $666.66. That's what 2/3 represents. Okay, find the mean claim. Okay, the mean claim will be the integral from 2/3 to infinity of x times f of x dx. So it's going to be math 2, the integral from 2 divided by 3 infinity of x times fraction 8 over 9 x to the power of 4 dx, which is equal to 1. Therefore, the mean, e to the x equals $1,000. A claim of more than 2,000, find the probability the claim is large. So the probability that x is bigger than 2 is 2 to infinity of f of x dx, which should be, it's not the mean, so let's get rid of that x. It's going to equal 1 on 27. And we now have a conditional question. Probability that it is large, x is bigger than 4, given that it's large, which would be the probability that x is bigger than 4, given x is bigger than 2, and on a number line, bigger than 2, bigger than 4, the overlap is probability that x is bigger than 4 over the probability that x is bigger than 2. So it's going to be the integral from 4 to infinity of f of x dx over 1 on 27. That's going to equal, so let's bring up a fraction. Let's put that in the denominator. Let's put that in the numerator and make that 4. That's going to equal 1 on 8. Okay. Part 3, a random sample of 10 claims, so n equals 10. Probability that more than one claim is considered large. We've now moved into binomial, and the probability of large from the previous page is 1 on 27. So x is now binomial, 10, 1 on 27, and we are wanting more than one claim. Probability that x is bigger than 1 equals the probability that x is bigger than or equal to 2, which will equal binomial CDF from 2 to 10, 10, and 1 on 27. So interactive distribution, discrete continuous distribution from 2 to 10, 10, and 1 on 27. And we get an answer of 0.050659, and we're doing 3 decimal places to 0.051. The household has 2 cars. Insured with company A. For each car, there is a 20% chance of a claim will be made next year, independent of each other car. A claim is also independent. At most, a claim can be made. Okay, so I'm thinking that we can have a claim or not a claim, so 0.2, or it could be large, or it could not be large. And that's 1 on 27. So 0.2 times 1 divided by 27 gives you 1 on 135. So the probability that you make a claim and that it's large is 1 on 135. Well, probably the next year household makes at least one claim classified as large. So we have two cards. So I'm going to call this Y, and it's going to be binomial. I have two cars, and the probability that a car makes a claim that is large is 1 on 135. And I'm wanting the probability that Y is at least 1. Therefore, I'm looking for binomial CDF 1 to 2, 2, and 1 on 135. So I'm looking for 1 to 2, 2, and it's going to be 1 on 135. And that gives me 0.014759, and we're doing 4 decimal places, so 0.0148. Okay. Let T of A be a random variable that approximates the time taken for a company A to settle a claim. So it's normal with a mean of 32 and a standard deviation of 7. Find the probability of TA being less than 45. So probability that TA is less than 45 is going to be a normal CDF minus infinity to 45. 7 is my standard deviation and 32 is my mean. Lower is minus infinity. Upper is 45. Standard deviation is 7 and the mean is 32. And that's 0.9868355, and we're doing 3 decimal places, so 0.968. Company settles the Polani 99.7 claim up to pay days, so that's 32. I'm looking for A, where that is 0.995. So I'm going to do an inverse normal, where the left probability is 0.995, 7 and 32. And that should give me my F, my K value. So inverse normal CDF, left is 0.995, standard deviation is 7, mean is 32. So that's going to K equals 50.0308, nearest whole number, K equals 50. Company B also offers car insurance, and I'm doing random sampling now. N equals 80, X equals 76, 95% confidence interval. Okay, so I'm going to go to statistics, I'm going to go to calc, I'm going to go to interval, I'm going to go to 1 prop Z, and I'm going to go across. My confidence level is 0.95, X is 76, N is 80. Next, and there's my confidence interval. 0.9022416 to 0.99775, which is 0.902 to 0.998 as my confidence interval. Let TB be a random variable approximate time taken for company B to settle a claim. And so this is T of A. It's got a mean of 32 and a standard deviation of 7. This is going to mean a 25 and a standard deviation of 5. Sketch the probability of T of B on the same set of axes. Okay, so 25 is going to be where my mean is. So that's where my peak's going to be. Since this has a smaller standard deviation of 5 compared to 7, it will be less spread, but taller because the area still equals 1. So I might go up to about here. And I'd expect it to be almost touching the bottom 3 standard deviations. So 30, 35, around about 40 I should be here, and 1, 2, 3, around about 10 I should be here. So I'm looking for a graph that very hard to draw with a tablet. Imagine that's less bumpy and more smooth, and that's going to be T of B. Done.